Hey everybody, so today we're going to be talking about constructing and interpreting scatter plots. We've moved on from box plots. So let's start with how do we go about constructing a scatter plot? And this particular one is about a burning candle. So it's comparing how much time is spent versus how tall the candle is. So a couple things that we need to know about constructing a scatter plot. You need to have a title. So easy enough, you just take the title from the table of information or the data that you've been given. Now time is typically our X value, so any time that you see time, days of the week, months, whatever, that's always going to be your X. So it's time, and our time is represented in hours. And then here on the side will be height. Now, if this was on my own piece of paper, I would take my paper and I would turn it to the side so that I could write nicely. Not having that opportunity since I'm on a computer screen, I'm writing to the best of my ability so that it stays there within that space. Now, when we determine how to create our areas here, we want to look and see what data has been given. What are they counting by? How much space is needed? So if you notice, we're counting by half hour, and it goes anywhere from 0 to 4. So this is going to be my 0. Now if I went half hour 1, 1.5, 2, 2.5, 3, 3.5, 4, I can actually fit all of that on there. Sometimes we can, but rather than having to write each number, I'm just going to write the 1, 2, 3, and 4, and understand that if it's in the middle of these two, that's where my half hour is. Then I'm going to look at my candle information. If you look, the highest it goes to is 8. Well, if I look, that's 1, 2, 3, 4, 5, 6, 7, 8. I've got more than enough space. So I'm going to go ahead and count up by ones. If it's a small space or you have big handwriting, you can do kind of like I did. You could skip a number each time and just put your 2, your 4, your 6, and your 8, and then kind of work from there. Mine isn't too horribly messy, so I'm able to put all my numbers. So at 0 hours, the candle is at 8 inches. So what that means is that before we start burning it, the height of the candle is 8 inches. A half hour after we start doing it, the candle has moved to 7.5 inches. So about midway between 7 and 8. At 1 hour, it's at 7.2, so it's just a little bit bigger than 7. At 1.5 hours, we're down to 7. At 2 hours, we're at 6.7, so make sure you're more than midway. At 2.5 hours, we're at 6.5. At 3 hours, we're at 6.2. At 3.5 hours, we're at 5.9. And at 4 hours, we're just a little bit more than half. At 5.5, 5.6 inches. Okay? So you can see as time goes on, the candle's getting shorter. Okay? Now, on your paper, you'll see that there's some questions. I'm going to kind of hold that in there, and we're going to look and see what the questions are. So let me move my picture out of the way. First thing it said is construct the scatter plot. Be sure to include the title, labels, and intervals. We did all that. Would you say there's a positive correlation, a negative correlation, or no correlation? Well, in this case, we'd say there's a negative. Just like there's a negative slope, negative correlation looks the same. And it looks like it's going downstairs. Describe the relationship between the variables. So as time passes, the height of the candle gets shorter. Based on the data provided, do you think 5 inches is a good estimate for the height of the candle after 5 hours? I would say yes. Because it's losing about 1 inch each hour. Now, I'll quickly just go back and look at it. But if you look at 5 hours, being at 5 inches kind of makes sense. It's going down. It might be a little bit below it, but I'd say that that's fair. Provide a possible reason to explain why there does not appear to be a constant rate of change. Well, a constant rate of change means that it's losing the same amount of inches or height every half hour or hour. Since candles work off of heat and it changes, or the temperature of the house might come into something, so it could be the temperature of the room affecting it. It could also be that burning a candle just isn't going to be constant. There's many factors that could come into play. So I would say the temperature of the room might have something to do with it. Now, we just said the word negative correlation, and we were asked about positive correlation or no correlation. Now, scatter plot's a little different. It can be that over different data, you can end up with a lot of points that are kind of just together. Now, what happens, though, is your dots, if there's a positive correlation, are moving kind of like a positive slope does, but there's not going to be just one set of points. Now, we saw it with the candle because it was one candle. It was just burning. So you're not going to see a lot of change. But when we do something like this, it might be that you have a collection of things, whether it's looking at test scores versus how long you studied or something like that. The more you study, the higher your score. That can change. It's not guaranteed that if I did 8 hours of studying, I'm guaranteed 100. But what it does say is that if I get 8 hours of studying, I'm going to get a higher score than somebody who does 2 hours of studying, because that makes sense. We could do the same thing with negative correlation. It kind of has this downward approach where we see this happening points, but apparently my pen wants to do whatever it wants to do. We see where it's going down. No correlation means that you just don't see a pattern. And with no correlation, we see that it's all over the place. So look in your own classroom. If we say we have a room of 14-year-olds, which as 8th graders, that's basically what we have, or soon to be 14-year-olds, or recently left the 14-year-old age group, and we compared your heights. We can be all over the place because being 14 doesn't mean you're a certain height, in which case we'd say there's no correlation. So now we're going to look at these and determine if it's positive, negative, or no correlation, and also what is it that they're talking about here. So here we have runners that are represented. This is their distance, while this is their pace. It's kind of taken off of there, so how fast they're running. At a mile, we seem to be running faster than somebody at 10 miles. I would say this is a negative correlation. And I would say the further you run, the slower your pace. This is accumulated snow. This shows how many inches of snow versus the amount of sleep. And you can see there's no correlation. So how many inches of snow you get has nothing to do with the sleep. I'm going to say it out loud. I'm not going to write it. And then this last one is the drama club. And it shows how long they've been around versus the number of membership. This is a positive correlation. And it seems the longer they've existed, the more members they get. So each year they add members. Each year, more members added. Okay. The last ones are for you to do, but I'm going to go ahead and do it myself. This is a positive correlation. And we say that the longer time that you spend practicing with batting, the more hits you're going to get during the game. Here we have a negative correlation. This one's about book sales. It seems that the longer you go out past a book being released, the less that you're going to sell of the book. And then finally, this is a no correlation, and it's comparing the number of pets you have at home versus your math grade. Having more pets or less pets has no effect on your grades. And that's it. All right, have a wonderful day.